Given these four equations, I can take my working example that I presented before and calculate its cycle time. There is at the beginning a rework loop, followed by a parallel path, followed by an activity assess application, followed by an alternative path. I need to know for each of the decision gateways in this model what are the branching probabilities of each of the branches that comes out of this decision gateway. Let me assume that the probability of exiting the rework loop is 80%. The probability of staying in the rework loop is 20%. On the other hand, the probability of the loan being granted is 60%. The probability of it being denied is 60%. I can now go and split my process into single entry, single exit regions. I call them single entry, single exit because each of them has one incoming arc and it has one outgoing arc, no more. I divided it. Each of them corresponds to one of the four patterns for which I have an equation for flow analysis, and based on those equations I determine what is the cycle time of each of the blocks. The first one will be the cycle time of the body of the loop 1 divided by the probability of exiting the rework loop 0.8. The second one is a parallel path block, and therefore the probability of the entire block is the maximum of the different branches. In this case it will be 3. Then I have a simple activity assess application with a cycle time of 3 days. That is the cycle time of that block. And then I have an alternative path block where the branching probabilities are 0.6 and 0.4 respectively. So I use these as the weights and calculate a weighted average of the cycle times of the different alternative branches. I then add all of these up because we are talking here about a sequence of different blocks, and I find out that the cycle time of the entire process is 8.65 days.